We will study what are the benefits of using the logarithm in machine learning and what are those cases or situations where we use this. So to get that part, we need to study the properties of logarithm. Okay, the first is product rule. So I'm just writing the function. What it says is log of x dot y is equal to log of x plus log of y. Example, log of 2 dot 3 is log of 2 plus log of 3. Now let's stop for a second and think how this rule can help us in some situations, what those situations can be. So we know that probability, whenever we calculate a probability, is actually between 0 to 1, right? Either a probability can be 0 or it can be 1, or it can be between 0 to 1, right? So whenever we multiply any two numbers and which that numbers are lying between 0 to 1, and if we multiply them, that will lead to a shorter number, right? So if we multiply 0.1 with 0.1, it will give me 0.01, right? So if we keep multiplying the numbers between 0 to 1, eventually it will give me 0, right? If I keep multiplying 0.1, 0.1, 0.1 and so on, so it will basically give me the point 1, 2, 3, 4, right? So as you're seeing, the number from 0.01 gone to 0.0001, right? So obviously now we can say that multiplication is not the solution. Now how we can do that? How we can replace that basically? So if I take a log of this multiplication, then I can write this as an log of 0.1 plus log of 0.1 and log of 0.1, and this is the last one, right? So now we are saying that we are adding the values, right? So this property is known as floating point or numerical underflow error, right? So we prevented a number basically by approaching to 0. So another example can be that we can see the 0.000001, this is the one number, and 0.00002. We can see that there is a difference between two numbers, but machine will not make a much difference between these two because it is after fifth decimal this 1 and 2 is coming, right? Now if we take a log of this, then it will come, it is basically 10 the power minus 6, right? 2, 2, 4 and 2, 6. So log of with base 10, 10 the power minus 6 will be minus 6. And so for this number, the log of 2 in 10 power minus 6 will be log of 2 plus log of 10 power minus 6, that will be 1.4. So log 2 is 1.4 and this minus 6. So it will come minus 4.6, right? Now the difference between minus 4.6 and minus 6 is still observable, but when we giving this is very minute. So we basically scaled this, right? So this is much better than visualizing the difference between these two numbers, or multiplying this instead of doing the log of a plus log of b. Another rule is our power rule. Now this power rule says that log of a to power b is log of a, and this b will come here. Okay, so example, log of 2 power 4 is 4 of log 2. Base can be anything, base doesn't matter here, right? Now what is the use of this in computer science? Let's say we have some variable with the let's say 10 to the power 8. So when you declare this in your code, it is basically storing 10 to power 8, right? And you can see that this number is very large, so the bytes or the memory required to store this number will also be large. Now how we can reduce this? If we take log with base 10, 10 to the power 8, then it will come as 8. So now tell me, storing 8 is easy or 10 to power 8 in terms of memory? Obviously 8. So this is the another use. So we can say that power can help to basically scale that variable to reduce the size in terms of memory of that variable. There are some standard rules which we should know while studying something related to mathematics, okay, in logarithm. So another rule is quotient rule. Now it simply says that log of a by b will be equal to log of a minus log of b. Now another rule is change of base. So these are certain rules which we must know. We don't know when we can require this, right? So we are writing log of a b. Okay, so the base is a and we want to make base a into c. So what we will do, log c will be divided by log of c and a will come. So this is the formula for converting base a into c. Okay, now we will see how we came to this. So let's say that you have log base 2 16. Okay, let's say that it is equal to x and you want to change 2 into 10. So you want to change this base 2 into 10. Okay, now if this is the equation, okay, what I can write is 2. So from now recalling the standard definition of log, that some power of base will equal to this. So we can write this, right? This is from the standard definition. Standard definition of log, right? This is my step 1. Now my step 2 is take log of both sides with base 10. Okay, now this is in power, so from power rule we can write this x log is 10 2 log is 10 16. Now divide both LHS and RHS by this term. So this will be x and log base 10 16 log base 10 2, right? But we want to achieve this base 2 to base 10. We did the same. So we came at this 2. So this whole equation can be written in this form when the base is 10, right? I hope this is clear. So the last one I want to discuss with you is that let's say this is an x and in the x power y is written, okay, but with base p. Okay, so what it is saying that this x and this y are interchangeable. So we can write this y to power log x with base p. So this is the property, again a new property you can use in while deriving some equations. Okay, so this is a very short video on logarithms. I hope you like it, and if you have any doubts, please mention in comments.